Hello everyone. This will be second video on time and work, and before proceeding further, I would recommend watching the first video on time and work so that you don't get confused for where these values are coming from. And this is for those who haven't watched it yet. And in this video, we'll be discussing some medium level questions. So let's see our first question. A and B can complete a work in 7.5 days. If A completes half work and then B completes another half, working separately, it takes him 20 days to complete. In how many days B alone can complete the whole work if A is more efficient than B? Let's try to solve it from a conventional method. We assume in one day they're completing one part of work. So in 7.5 days, total will be 7.5 parts of work. This will be our total work. And as for efficiency, we assume efficiency of A to be n, hence efficiency for B will be 1 minus n. Let's try to solve it. 1 by n plus 1 upon 1 minus n is equal to, they are taking 20 days and working half. So 20 days by their total work upon 2. 2 is because they are working half and half. Now if you solve this, you will get an equation, quadratic equation, which will look something like this: 16n square minus 16n plus 3 equal to 0. Doesn't this look beautiful to you? When you started, you had a question as to what will be the value for B, and then while finding the solution, you ended up having another question for you. Well, I don't think so you want to follow this method. Let's see a competition safari method. We have 7.5 days and its percentage value will be 13.33. You will be wondering, I haven't written 7.5 days value. So here it is. You have 7.5 days, which is half of 15 days. And in one day, 1 by 15 day, if I'm completing 6.67 work, and here we have 7.5 days. So if I'm completing a work in 15 days, and then if I'm completing in 7.5 days, it means I am twice more efficient when I'm completing it in 7.5 days, which means I am doing twice more work in one day. So 6.67 into 2 is 13.33 approximately. So you have 13.33 as your percent value. Now you have to break this value such that they both sum up and they give you 13.33, and both the values should be from this fraction table. So our first possibility is 10 and 3.33. Our next possibility is 8.33 and 5, correct? Now let's verify our different possibilities. Let's assume this is your complete work. You have 50% here and 50% here. This is territory for A, this is territory for B. So for completing 50% of work at rate of 10% a day, it will take him 5 days. And for B, it will take him almost 15 days when he's doing 3.33% of work in one day. Add it up, you will get 20 days. Our next possibility, 8.33 days, which means in completing 50%, it will take him 6 days. At rate of 5%, B will take 10 days. You add them up, you will get 16 days. Now, it is given in the question that it is taking them 20 days when they are working separately. So, it is taking them 20 days when they are working separately with different efficiencies. So, this option, this possibility right here is our correct answer. Now, there will be questions where you might or might not get different possibilities. So you don't have to worry about it. You just need to put the values and cross-verify it with the data given in your question. And I think it is still a lot easier than the conventional method that we just discussed. I think it's a good question. And let's see our another question for today. Well, I haven't done much here. I've just jumbled the values, the data given here, just to cross-verify our method. So you have 12 days, and for 12 days, you have a value 8.33%. There's only one way where you can split it by taking the same values from this fraction table, which is 5 and 3.33. Now, it is mentioned in the question that A is more efficient than B. So you might think that I could have put the value 5% here and 3.33 here. Well, it will be mentioned in your question. The same thing goes here. It is mentioned that A is more efficient than B. A is more efficient than B. A is more efficient than B in both the possibilities. So before jumbling the percentage value, look into the question for more data. Coming back, we have just one possibility here, and so we'll cross-verify 50%, 50%, 5% a day, which means 10 days, 3.33, which means 15 days. Together the 25 days, not percent. Now you have to find the value for B. You see your 25 days is matching with the data given in the question. So you have to find in how many days B alone can complete the work. B is doing 3.33% of work in one day, which means it will take him 30 days to complete the work. Similarly, here also, B is taking 3.33 percentage. B is doing 3.3% of work in one day, so it will take him 30 days to complete the work. That was our question, and your answer is here. Now, moving to our third and last question for this video. 12 men and 16 boys can complete a work in 5 days. Let's keep writing the data. 12 men, 16 boys, doing some work in 5 days, and 13 men plus 24 boys can do the same work in 4 days. Since their job is same, the total work will remain same. If you solve this, you will get 60 men plus 80 boys equal to 52 men plus 96 boys. We have 8 men, 16 boys. 1 man is equal to 2 boys. So 1 man is doing work equivalent to 2 boys. Let's put this in our first equation. 12 men plus 16 boys are replaced by 8 men. This is the work done in one day. So in 5 days they are doing 20 m into 5 is 100. So total work is 100 parts, and we have to find for 6 men and 8 boys. Well, 6 men plus 8 boys will be 4 men, which is 10 m. This is the work done in one day by 6 men and 8 boys. So total work is 100 parts, and parts done in one day is 10 days. It will take them 10 days, and it will take you almost 2 minutes to solve this question. Well, I don't think you want to do this. Again, we'll cancel that out. Now let's check our competition safari method. You have 12 men, 16 boys. You have to find for 6 men and 8 boys. I think you are genius enough to find the relation between these two. Well, this value is half of this value. So if I have reduced the workforce by half, I have reduced their efficiencies as well. And since I have reduced their efficiency, it will take them more time, which means they will take twice as much time to complete the same work. So you had 5 days here when 12 men and 16 boys were working. You have reduced it by half to 6 men and 8 boys, which means it will take 10 days to complete the work. Wasn't it easy? Well, you have to look for such data in your questions. It will make your process very easy and quite compatible to work with. Let's assume some another value. We don't have 6 and 8. Let's say we have 24 and 32 boys. Here we are increasing the workforce by 2 folds. We are also increasing their efficiency by 2 folds, which means the time taken them will reduce by 2 folds. So if they are completing it in 5 days, here when you have increased the workforce, they'll be completing the same work in half the time, correct? So half of 5 days is 2.5 days. Well, in examinations, you have to keep your eyes open for such data. Even though your data won't match as total integral parts, like 12 and for 24, it may be something like I have increased it by or decreased it by 3/4. So 3/4 is how much of this? 9 men if I'm not wrong. And 3/4 for this is 12 boys. So you can depend on the fractions also for the change in data. 3/4 for 12 is 9 and 3/4 for 16 is 12. So 3/4 for 5, and you can find your answer. Oh, again we have fractions. Well, we have this is your answer. Just keep your open to eyes to data given in the questions, and it will be easy. Well, this is the end of the video, and see you in our next video on time and work part 3.